discussion about some of those topics. So feel free to throw to our colleagues any questions about any topic we've discussed today or will discuss later in the week. Just to kick it off, I'd like each of the panelists here just to give a quick 30-second summary of who they are and the context for this session, which is about opportunities and challenges that have come out of some of the discussions and the presentations we've had today. So with no further ado, I'm going to pass this over to David.
Thanks. So I'm Professor David Williams. I direct the Geotechnical Engineering Centre, which actually sits within civil engineering at UQ, and I'm in this building, but of course we cross over into mining and also earth sciences. And that's just by way of a quick introduction. I just wanted to raise a few key words. So one is, and you might just keep this in mind, big data. I think optical fibres gives you the opportunity to collect big data. And you hear some of the major mining companies talking all the time about big data. I think they collect it. I'm not sure what they do with it. So big data, that's one. Damage. What sensors can we use to indicate the onset of damage? And I'll talk about an example of that later. The chicken and egg situation. You know, do we know what we're the unknown unknowns? Do we really know what we're trying to sense? And I think that it's a very broad topic that this conference is discussing. So a very broad brush group of individuals. I think it's hard to connect them because they often come from different disciplines. So hopefully this discussion will help that.
Thanks very much. Myself, I'm from an OEM, Diego Damiani. I'm responsible for crushing and conveying a company called Joy Global. We manufacture equipment for the mining industry. There's some information coming up shortly. And as an OEM, an original equipment manufacturer, we really provide the link between the R&D facilities. We do R&D ourselves, but we go to expert facilities like the UQ, many others, Mining 3 as well as CSIRO. And we extract that knowledge, convert it into products, and work with end users to sell them the product. So from our perspective, the commercialization, an intrinsic part of what we do, really important to understand what the end user is looking for. So from my perspective, definitely not an expert in photonics or fibre optics, but very interested to understand what and how the technology is developing and how we can convert it into products for end users. So we'll be talking more about the implementation of technology and ongoing support.
Okay, my name is Liu. I'm the technical advisor to the BGP, which is the largest onshore geophysical company in the world. We have about 30,000 people actually. In the oil industry, actually, we see the application of the optical sensor technology being gradually developed in the last about 10 years, and it's moving very fast. Today, we have the service facilities such as pipeline, storage tank, all being monitored by DTS and also the DAS system. And this is very widely being used, at least in China and also other countries. Now, for the oil field, now we're doing what we call the smart field. So we need to know more about our oil field. And this is looking at lifetime development, monitoring, and measurement. So we have a DTS, downhole measurement, in many boreholes worldwide, pre-installed fiber. We measure pressure, temperature, and also the flow rate. Today I talk about the seismic, that's also a small part. So in our industry, we need a lot of support from this new technology, new sensor development. For fiber optical sensors, there's two important things. One is you don't need the power, which is very good for our downhole application. Secondly, downhole had a very high temperature, very high pressure problem. We cannot put electronics down there for a long time for very high temperature borehole. While fiber, you get a 300-degree fiber you can put down there forever. So this is the way attracting us for our downhole harsh environment measurement.
Thank you. My name's Jeremy Davies. My, connection with the optics community is that about 35 years ago, I'm ashamed to say, I spent some time in the auto industry developing full-field electronic speckle pattern interferometers to measure vibration and strain of structures, automotive structures, non-contacting technologies. So it's personally very interesting to see how the fibre systems have developed from there. But my learning from that, and it took me probably about 3 years to learn it, was that engineers really didn't care less about optics. They couldn't care less. They were automotive engineers. What they wanted was answers to questions about how their structures are behaving. They didn't care whether I used optics, whether I used photoelastics, whether I used strain gauges, whatever. If it was better, faster, cheaper, more accurate, more reliable, and it gave them the results they wanted, that's all they were interested in. It took us 3 years to actually end up creating a desktop which translated the work we were doing in optics into a format that they were comfortable with and would use. And at that point, we got some take-up of the technology. Up to that point, people just looked at us as if we had landed from Mars, frankly. So I thought it was interesting, in one of the papers this morning, someone talked about a desktop that pulled things together and translated information into custom and meaningful formats.
I'm John Canning. I'm from the University of Technology in Sydney, and I've been involved with a number of startups over the years, the most recent ones being ranging from biomedical through to getting some railway technology into Australia, some photonic railway technology. And perhaps the more interesting one, in some sense, is the development of photonic guitars. So covering that kind of range, it's interesting that there are some similarities across those areas. And the other thing that strikes me is there's always been tension between what universities do, the basic research, the applied research, and sometimes, perhaps, arguably, the irrelevant research. So you see some stuff which is quite difficult to define what the purpose is and what it's for, which is a little bit different from basic research. So it'd be interesting to hear what the panel members have to say on that and how that might improve future collaborations and interactions across all parties. So, and I guess in general, photonic sensing has been around for a long time now, decades. It's been very slow in being adopted. So if you imagine that some of the fibres that were developed were originally not for telecom, they were for sensing applications, and arguably the earliest were for the inspection of cadavers. So people would stick in these coarse pipes that guide light just to see what was inside a dead body. And so that was some of the earliest imaging applications. And then it actually went through a phase of developing optical fibres for TV. Even some of the early TV designs were around optical fibres. They didn't work that well, but they nonetheless. And then, of course, eventually it really hit the big time when it impacted on data transmission, therefore telecommunications. And now it's coming back, and there's a convergence, you could argue, of big data, as was mentioned earlier, and fibre optic sensing. But also now with the Internet of Things, there's the hookup between fibres and wireless. So you're getting a very broad spectrum technology that's really about to revolutionise things.
Hello. Yeah. Good evening. My name is Mark Jones. I guess I would describe myself probably as an international entrepreneur. I've spent the last 30 years working in large corporations and the last 10 years working in mining, particularly with mining technology startups, in which I've invested in a couple. And it was through that I became involved with METS Ignited. And METS Ignited is an organisation that has only been around for about 18 months, and during that time we have put together this document, which you can download from our website, which is called the 10-year sector competitiveness plan. And that is around what we in Australia are interested to do to have an industry-led approach to innovation and commercialisation of innovation within Australia to accelerate that. and to get new ideas, both in use in Australia and overseas, as quickly as we possibly can. So for me today has been fascinating. I very much thank the organisers for inviting us along, because I had no idea what the whole fibre and photonics was completely new to me, so I've had a fairly steep learning curve, but what I can see has interested and piqued my interest, particularly given some of the elements that the previous colleagues have discussed on this panel, so I look forward to the discussion.
Hi, my name is Steve Amor. Up until Friday I worked for Anglo. Anglo is a global mining company diversified across multiple commodities. And I was in the technology development group who look at futuristic technologies. The reason that I'm involved with this conference is that whilst I was there, I personally did a lot of work on a number of projects that involve fibre optics. Some of them we've talked about today from various organisations, and one of Anglo American's visions was for what they call pervasive sensing. That was cheap, fast capture of lots of data, or big data as we talked about, and that was across a mine site. So there's an understanding that the more data we can collect, the more that we can understand what's going on. But the other side of what I wanted to make sure we talked about was also on the commercialisation or the bringing to the market of the technology. One of probably my biggest challenge was not the technical side. That's for, as Mark said, we don't really care on how it's done. What we do want to do is get it so that we can use it. So that's just a reminder to everybody that sometimes speed is more important than the bells and the whistles, and making sure that you talk to the end user about what it is that we want.
Hello, my name is Tongyu Liu from Shandong Academy, China. I'm leading a research group on the fiber optic sensors, and also we have founded a company, spin-off company, to commercialize the fiber optic sensors. So in the last 10 years, 12 years, while we are doing this technology transfer, what we found is it's not easy to make the fiber optics to be acceptable by the industry, because you have the electronics device very powerful and very low cost, very robust, and we've been struggling to find out the application area where there is a real need. So one of the areas identified is to do with the conference topic, the safety. So safety, particularly in the chemical plants, in explosive, dangerous areas, such as coal mines, where electricity is not that suitable. So the fiber optics is in a very unique position, being attractive to that industry. So that's why we thought, okay, in order to bring the technology into industry, we'd better to find the industry which really need this. So clearly there are lots of needs as the conference develops. From my own experience, on one hand, many fiber optic sensors we talked about will be required in the industry, but they are more useful for the fixed location, for fixed equipment. Because with the fiber as a tail, you can't really take it everywhere to the mobile. However, talking about IoT, Professor Jeremy talked about, IoT is everywhere, not just a fixed place, also with mobile. So therefore, one of the challenges for the photonics, for the fiber optic sensors or laser sensors would be how to make it also mobile. which means keeping the advantage of all the good things, performance with the optics, but still need to be very low cost, very robust. That's one of the, I think, one of the aim we are asking the photonics community, because only when you have make it to the mobile, then you really have a big market. Also, another thing is we know the plastic fiber is much easier to handle. To join them together, just need a scissors and scissors, pair of scissors. You don't need a fusion splicer. However, many of our sensors are still using grating or scattering, which mostly use single mode fibers. So therefore, there is a challenge how to use the, maybe looks like low cost or low technology fiber, but the industry maybe just needs that. I think things like that would be, a lot of things need to develop. So, thank you.
Thanks, Pamela. Could I open this with a question to Diego? We've talked a lot about very specific sensors. Could you talk to us about the challenges you see using these sorts of technologies at a massive scale, and the sort of equipment that we see on the mining side?
Thank you, Jeremy. What's playing up there behind us is a little bit of promotional information about our company, but it's really it's an explanation of how a mine site works. It's really our equipment, but it's multiple pieces of mobile equipment, and what we work towards as an OEM, as a solution provider, is having smart connected equipment that's being continuously monitored. So from an end user's perspective, a solution provider, it's understanding how we can connect that equipment, how we can make it continuously being monitored, and then the analysing of that information. Now, I've heard probably half a dozen times, if not in this introduction, but definitely during the day, about big data, the Internet of Things, and on that representation up above, you'll see the Wi-Fi symbols beside the machines. It's really connected information. 5G, we've talked about 4G, it's extracting data out of mine sites and then quickly turning it into information, but not information for information's sake, it's information to make decisions with. As an end user, Steve, I'm sure you can validate the fact that action is needed from the information, because many a time we collect this information, even at an end user's perspective, and it sits in trays, it sits in emails, and it doesn't really get action. So it's turning that information into action that we're trying very hard as an OEM. So what I picked up here today is really the implementation of technology from our perspective is important, but the technology that I've seen here today is really they're stepping stones, and it's a pathway to automation. Because what we work towards from an equipment perspective is automating the equipment, and to be able to do that, it's again that connecting the data, understanding its condition, monitoring it, and being able to take people away from harm. So safety, I know, is another topic of the conference here today. Automation is a pathway to being able to take human life out of harm's way. So from our perspective, all of these technologies are interlinked, and it's important that what I've seen here today, at least from a monitoring perspective, from a fibre optic and the multiple areas of being able to have a single sensor, multiple elements that they're monitoring, for example, it's very important. The dynamic and variable resolution that we picked up on the last presentation, smart monitoring, linking it together, very, very important for us. Speed to market, supporting again what Steve just brought up, is taking something from a concept and bringing it to market. So, Jeremy, to answer your question about, from my perspective, what's important for the scale of the equipment that we work with is predictability and understanding that link between R&D, commercialization, and then implementing the product in the field. So we're working towards getting early adopters, and they're very hard to, especially from a mining perspective, risk-averse companies. Although people like Steve and his team push the envelope with regard to R&D, a lot of mining companies are risk averse, and it's important to communicate the good work that's happening in research institutions and educational bodies like UQ, and take that to customers so that they can understand that. When I say customers, end users, they can understand that and become early adopters. So from our perspective is being able to provide that cohesive message, not just from an R&D perspective, but that value equation as to what we can bring to their business and improve their bottom line. And we'll have a bit of discussion shortly about a P&L impact. And there's probably not enough discussion here today about there was talk about end markets and how big they were, but not really enough about an end user's real profit and loss impact on a day-by-day, month-by-month, year-by-year basis, and that link is important.
So, with that, can we open this up to the floor? What questions have you got? Oh, I think there's a roaming microphone as well, please.
Very interesting. Maybe to pick up on the profit and loss. So clearly, in the context of mining, there's a commercial imperative, but there's this broader community, society that we live in, and if you were there for my presentation this morning, and you pick up on the media, I mean, there's a real crisis around the world associated with pollution, mines in particular, and there's no commercial imperative. Nobody is taking ownership of the problems I think that we're facing as a society, and I just wanted to get your perspective. And you know, price and loss, P&L is good, but how do you apply that in that broader context? Because as per my slide, and this is available, it's costing the global economy, I think
Carbon tax.
well, let's be controversial, I'm being provocative. It's costing the economy $5 trillion. $9 billion a year in Sydney alone is air pollution.
Who would like to? Yeah.
I think this is a fabulous topic, and I say that as a man who's currently doing a Masters in Sustainable Mineral Beneficiation and looking in particular at the application of technology to obtain the best financial, social, human and environmental outcomes. And why? Because we can. And it's actually not that difficult. What we haven't had, though, is necessarily a focus on those outcomes, particularly at the operational mine sites, and particularly for some of the larger mining corporations who traditionally have made a trade-off, which is to extract a depleting resource and have a negative environmental impact, create a positive financial capital outcome, and generally speaking have ignored the social, human and environmental outcomes, all of which have had negative impacts. So when we start to look at that and dissect that, we say, well, what are they saying at the companies? You see the ICMM, which is probably the core body of CEOs of the largest mining companies, and they're all very much of a view that they should be adopting an approach which is across social license, but some of them are struggling to say, well, what does that then mean? You've got the banks who are suggesting that they're not going to finance anything if there's going to be some, unless it's social, there's been a social license obtained, but the latest research from SMI has suggested that the cost of conflict is extremely high, both in this country and around the world. So there's a mismatch. What's interesting though, and I think what we've seen today, is a variety of technologies, and in particular these technologies, but we haven't necessarily seen how they can connect to providing the data that would actually drive some better outcomes for an environmental impact, a social impact. I mean, dust, for example, is a fundamental one in the Hunter Valley. It was mentioned earlier today. Monitoring of that and maintaining that. And I've got an investment in a company that is a mine planning company. We use dust as a constraint in the strategic planning of a mining asset. Now, you can do that if you know anything about it, if you can sense it and you can understand what's going on. If you can't, you can't. But the possibilities that it opens up are quite extraordinary. So for my interest in this is actually transforming the global mining industry in the way in which it's able to obtain financial, human capital social capital outcomes and environmental capital outcomes through the application of technologies, many of which are already there. So it's not about the technology as such, it's much more around helping people, as I think was mentioned by Steve and by Tongyu, around helping people to understand what they can apply and how that's going to derive an impact which is going to be a benefit to them, and focus in on that. So there's actually, I think, a human shift here, not so much a technological one.
Could I ask Tongyu to respond to that? I mean, very recently we've seen some scary images of cities in China who are clearly seeing some serious impacts from industrialisation. Is that the sort of lever that will cause the sort of change that we're talking about, on the scale we're talking about?
I think clearly in China, the government, you asked about the ownership of the problem. The government has got enormous pressure from the society, community, because it's there. You can't hide. So I think the government is taking very strong action. But on the other hand, it takes time.
It's not improving, that's the thing, it's getting worse, it seems. And at a national level here, it's not clear that governments are taking ownership of our own challenges, not that they're of the same magnitude anyway.
Can I make a comment? Fernando Vieira here. Mark, I enjoy your comments and those that you pose as well. Isn't then the issue about searching for technologies that change the way we mine? Because right now, and this particular conference is about one set of technology that will not change the course of mining. Yet mining is a societal demand, whether we want it or not. We are in mining because society wants it, and more demand for minerals are out there, and it's foreseen that it's going to happen in the future. So I think if you want to revolutionize the impact in society, the way the footprints affect and the way operations affect society as a whole, we need to consider bringing about new technologies that extract mineral without increasing the footprint. And we don't have those technologies. If there is some conference to be developed about, is in fact about that development altogether. Yeah.
Can I ask you a question on that? What do you think is the mechanism that causes that to happen? Clearly, the mining industries won't do it. To date, they haven't done it of their own, for their own personal reasons.
Yeah.
So what do you think? What do you think is the? I agree with what you say, but what do you think is the mechanism that causes it?
It's a technological problem. Let's not forget about it. In fact, if we appraise mining the way we do it today, it hasn't changed. The methods of mining haven't changed for hundreds of years. We do still drill and blast and remove magma and cause dust and cause toxic fumes and pretty much cause all sorts of accidents and environmental constraints. Will there be a way that we mine without removing that much dirt? Do we place mining, do all sorts of in-local mining without actually increasing the footprint? And precisely the technologies I was talking about today that need to be developed, the separation, early separation of ore and waste without processing, such quantities, huge amount of materials just to extract a small portion of metal. That sort of notion, the way we mine today needs to be changing, and we should develop that thinking as we speak.
Can I perhaps make a comment on that? Because my view, and it's a fairly strongly held view, is what gets measured gets done. And in mining, the only thing that gets measured is the quantity of tonnes produced. It tends to be. So there's not a lot of information around other items which are measurable. And, or if there is, it's not used as the basis for driving change. So I would say that any change would need to have a radical impact, and I call that 30% or more, on revenues, costs, social outcome, human outcome, environmental outcome. And needs to be measured across all of those, because if you're reducing toxins by 30% plus, generally you're making money as well, because you're not having to clean it up somewhere now or later. If you're increasing safety, you're not killing people. So you've got these things have to be measured and have to be driven in some ways by the companies themselves. And in most industries I've ever been involved in, I've been involved in banking and retail and fast-moving consumer goods. That's generally been the way that it's gone, has been things have gone poorly. There's been a crisis, and most recently in mining there's been a commodity crisis, and or in China where we've got a pollution crisis, and in leadership, never waste a crisis. Use it as the fulcrum to go and drive some radical change where people will try something different than what they've done before. But the thing we're moving against is the inertia of the existing mindset around how to run things, which is tough.
Tongyu raised the point about ownership by broader society, i.e. government to some extent. And I think it's very difficult to get around that. If I look at another industry like the oil and gas sector, and you see what happened with that Texas oil field crisis around Florida at that point there, they had less safety protections and installations than Petrobras systems in Brazil. And the big reason for that is fundamentally that the Petrobras is a state-owned or part state-owned enterprise, and it has certain obligations. So Petrobras actually funds a lot of cutting-edge research. It has to. So it's not the only solution, but there has to be some ownership of the issue. And also, at the moment, in terms of issues like dust and so on, there is a carbon tax scheme that's been discussed worldwide precisely to address the kind of issues that you're talking about. But not everybody wants that, because they see it's a lot of work to try and transition the sector to a more efficient one. So anyway, that's just a quick comment on that. Is there anyone else with a comment or question in that area? Okay.
Just a question on the mining issue. Given the situation with certainly one of the problems about mining and mining safety is people, how close are we to taking the people out of mining so that mining is done remotely with robotic systems? And of course, being sensor people, robotic systems present us with an enormous opportunity to produce the sort of sensors which would help a robotic system to work efficiently. I know that doesn't solve the problem of what you do with the stuff when you get it out of the ground, but clearly one of the issues around the way mining is done at the moment is it's done on the basis of making sure the people are safe. Clearly you want to keep your robots safe because you don't want to lose them on a regular basis, but the constraints are obviously very different. So is there any hope that we might move to robotic systems which would help to alleviate some of the problems?
Not necessarily the term robotics, but automated systems definitely, and it's systems, integrated systems. But before I get to that, I noticed that we had a fairly healthy discussion, provocative questions about social impact of mining. I think we'll probably spend all afternoon talking about that. The R&D impact, I think, of taking information and using it for whatever function that either whether it's government, whether it's the individual mining companies, whether it's research companies, whether it's aeronautics, whether it's ports. I think it's just really collecting data and using it for information. So to answer the question about automation, it's definitely the next frontier. We're not involved in mining. Predominantly what we do is mining, but we're also involved in other aspects as well, including construction. And there's a lot of work. I noticed that you talked about tunnelling. The tunnelling activity globally now, I think, is at a peak. There's an enormous amount of activity in just burrowing holes under the city so that we can move either equipment or people or services. So the automation of equipment, I think, is the next frontier to take people out of harm's way. Inevitably,
I don't think that there's a single function within a mine that we're not working on for automation. And I think that that goes from full shovel automation even to drag lines, which are the very large cranes that are used, especially in Australia. They're all within a few years of being automated. Also, I get frustration from technologies that I see us developing that I think could become products, and there are people in this room that I would look at and say, why haven't you automated them yet as a product? But also don't forget, to go back to society again, I mean, there are many countries and locations in the world where South America, Africa, possibly China, I'm not sure, but some of our mining communities rely on mining and they rely on employment, and as soon as you automate too much and reduce labour, then protectionism comes in and governments take mines off companies to keep people employed. So once again, there's a trade-off with automation. But to answer your question, yeah, automation is on our doorstep for everything.
I thought it was already happening. I mean, we had the University of Sydney, a very big program on robotics funded by Rio Tinto for the last decade at $5 million a year.
Yeah,
They've automated mines up in the Pilbara.
That's right. But Rio Tinto was at the forefront for that. I think other companies like BHP Billiton and even Anglo American have all caught up. They've all got mines that are automated. But there's a massive capital cost. Our mines, don't forget, mines are typically 20, 30, 40, 50 more years life. So once you start off on a mine, it's very difficult to change the philosophy of the mine. But the new mines that are coming in, I think Vale's S7, S10, S11D, it's full IPCC, for example, which is there's no trucks left in that mine. It starts off. Other mines, you really have to wait for a fundamental change, a replacement of capital before you can bring in something new.
Just add a little bit about the situation in China, because for the coal mine, half of the production is made in China. So in China, the coal mine companies, there are three types. One is the state-owned, the other one is like a local state, and the others are private. So for the state-owned companies, these are very large, and the automation, so the state of automation is as good as Western countries. Some are certainly world class. And for those coal mines using more automated equipment, and the safety record also as good as if not as good as Australia, certainly close. Yeah. However, it's an economic issue, like they pointed out. For some remote areas, like in southwest China, people rely on the economy. They have to work. And also for some very poor condition coal mines, they can't really automate. But it's true, the condition is not that good. However, there is, apart from automation, there are also other ways to use energy, to develop energy. That is, I think many research done in Australia, in the UK, and in Russia, for many years, 50 years, try to do the chemicalization, gasification underground. So that is actually exactly where the fiber optic sensors is required. Because you want to make a fire, make a chemical plant underground without people, without electricity, then the fiber optic like DTS are very useful. Distributed gases in the sensor temperature, vibration. All these things will be very essential. Without those, it's impossible. But that's the future. If we can wait to dig the coal slowly, but currently it's just too much. Production level is a bit too much.
Another question?
Thank you very much for the discussion around mining. It was very interesting, and I've been around mining for a few years now. But I would like also to ask Professor Gang Yeo, I noticed oil and gas industry has been very supportive of of especially fiber optic sensing community and has taken up the technology in the best way to improve their productivity. So I'm wondering what lessons do you have for mining industry and the other industries to take lesson and learn from you?
I don't really know much about mining, but I think from all industries, we having problem today is looking at we're getting more expensive to extract oil and gas as we did 10 years ago. So everybody's trying to cut the cost. But the only way to do it is use new technology. The way today, if you look at US, we have shale gas production, for instance. Now, 2 years ago, the cost almost about $40 per barrel. Last year, they actually announced they can make up to $25 a barrel. So we can beat the market in Texas. You have some mature field, we have the existing pipeline. These are all due to the new technology applications. And the fiber optic sensing technology is it's not new to us, but actually to use more widely or into some place we never thought of before. It's something very challenging. The only thing I see difference on the something doesn't have learned is it's not like normal household items or surface equipment. In a downhole environment, we have high temperature, high pressure, and small space. And those are need more challenge, basically. For instance, like the measurement for temperature, TTS, used everywhere easily in the surface. But when you go to 200 degrees C, 25,000 psi pressure, do we get the same measurement? Or the measure has to be corrected for this environment? We measure the pressure, for instance. Today we have a measurement of pressure with optical sensor for a single point. But what we do is actually distributed measurement. There's no commercial product available today. And we're looking for very high pressure. Like we have borehole depths of 8,300 meter deep. The pressure is up to 160 megapascal. The reason is because the high pressure gas, that's why you have blew out. So the normal sensor doesn't really work in that environment today. We have no instrument. It's 270 degrees C. So no other commercial equipment can go down that deep at a high temperature, high pressure environment. So we're hoping the optical sensor really can be solve the problem. But before that, you need to look at such environment to develop the product. Anything developed in a lab, using room temperature, doesn't work in the environment. So the other problem is the corrosion. We have H2S gas. We have different chemical composition in the borehole fluid. And you are fiber. I guess there's hydrogen, what do you call that? The damage of the hydrogen will cause the problem with the fiber. And we are putting fiber down the borehole behind the casing with the cement. And we did that kind of work for 10 to 15 years. So for long-term monitoring applications, the reliability of the fiber is an issue. Like in China, in Dasheng, we put about 30 borehole with the fiber behind the casing. After 2 years, half of them was broken because of the ground movement of the piping. Ripped pipe, ripped the fiber. So a lot of the challenging problem actually we are now facing, which we have not really good answer yet. So I think the industry development now is to looking. I saw a lot of presentation in different conferences, very smart ideas, but how you get them to commercially available to us, the industry, is something like all the scientists, professors have to work on to challenge the real problem and solve the real problem. We cannot afford to buy any R&D product in the oil industry. You put downhole for 10 years, you're not going to do something only for 2 years. And the investment, if you put the fiber behind the case of the cement, you cannot get it out, basically. So it's done in one time and useful for lifetime. And those something I think is really challenging for the industry to face the real world problem in such environment. So I'm hoping, I guess, with the new development of all the different sensors, and I look at the sensor you have developed as every sensor can be used for oil industry. Chemical sensor, we talk about the co-balancing, detection. It's same thing for us. We are looking for measured downhole fluid, gas, water, oil, and only the chemical sensor, which today we are forced to take the sample from subsurface, put in the pressure chamber into the surface. That's a very expensive access. And the tool costs you $10 million just for the tool. But if you use fiber sensor, we can do this much easily, much quickly. As long as it's reliable, give us the correct answer. So I think a lot of the challenges for you guys to work on to use them in our industry, because oil industry is a very, very big industry in the world. If you're looking for the production, refinery, storage, transportation, just look for pipeline. We have probably about 5,000 kilometer pipeline in China. In the US, probably 100,000 miles. Those pipelines need to be monitored on every inch, basically. And that's a big challenge or big application for you guys. Now, also, Professor Zhao talked about this. We have this bullet train in China now. What was I think it was almost 15,000 kilometers. Now, they are not using fiber monitoring right now just around the station, not on the whole line yet. But gradually need to put on every inch of the railway to monitoring any intrusion, any potential deformation of the bridge. Those things have wide application, I believe, for the fiber industry to be used in the real world, and those are a huge market, I think, for you guys. Thank you.
Thank you very much for the comprehensive answer. I'll put another question for the panel. How do you think the ecosystem of the commercialization works in different industries, especially mining, oil and gas? So, starting from the idea and taking to the product. So we talked about commercialization a lot. So we have two sides to this, as you mentioned, entrepreneurship, small companies and startups, and the role of OEMs to making this ecosystem in mining industry and oil and gas.
Would you like to take that?
I think my panel colleague in his last answer was actually quite explicit about some of the challenges faced by industry. And what we actually see here in Australia that I think we do quite well is some of the CRCs where we actually, and I think CRC OR, which we heard about earlier today, we've got industry partners, we've got METS companies, so mining, equipment, technology and service companies, and we've got researchers collaborating together. When I see that, and if I look at Newcastle Institute of Energy Research and a number of other institutes around Australia, I won't go into them, but where it works really, really well, we've got an industry partner who's got a problem and a challenge, a big challenge. They've got to figure out how to do something, in this case, down, with very high pressure and a lot of heat. So that should be awakening, the interest of those in the research community and those in the commercial community to say, well, what can we do to design a product? And what's the interesting thing that we've discovered at METS Ignited is that in Australia, it works much better when we can share the risk. So when we can invest with a number of different mining companies and a number of different METS companies and perhaps a couple of researchers, so that we've got a broad coalition of people working on the same problem and collaborating around that. And what we're going to be encouraging in Australia in the next 10 years is much, much more of that, where there's, if you like, clusters of capability around particular areas, and we'll be looking to, China and Chile and other countries where there is, similar research and similar problems taking place, such that we can actually bring that together. And in particular, I think one of the key issues has been the proof of concept. So often ideas come in, they get to, prove the hypotheses, and then they stop. So technology readiness level 4. It's to move things through levels 5, 6, 7, 8, 9. So that's taking place in partnership, for example, with the OEMs like Joy, Caterpillar, some of these other large corporations that have got distribution networks, but doing that together with the customers, the miners. So, what Steve was talking about earlier is listening to those end customers so that you're designing an outcome which they're actually looking for and they want to buy. Because that's, at the end of the day, that's commercial is, making something somebody wants to buy because it does a job for them that they need to have done. And it's that simple.
I have a comment on that. You know, like I'm seeing the corporations as not taking risk entities, and I bring that. You know, like you can see most of the breakthrough technologies are coming from entrepreneurs, the small companies. You know, the example Professor Yu had today was the technology used Silixia, a UK-based company, which had a really good entrepreneur CEO that took it up to BP and Shell and got $20 million of funding to develop the technology. It's been a really breakthrough technology being developed by 2 or 3 other companies around the world, most of them in the UK. And, you know, like, how do you want to challenge that? I know Steve has a really good record of technology adaptation and the guidelines while I was working with him. So, you know, how do you want to change that corporate culture that's not taking risk to adopt new technologies and be, you know, think out of the box?
There's a few down here as well.
I'll start. I would challenge you that the mining industry isn't necessarily conservative. I hear it a lot, and I know why. I think it's about who you engage in the industry, and I think the large companies have groups like the one I was in that are specifically looking for futuristic technology. I think that researchers do a poor job of understanding what the end user wants, what the problem is, and that's not just the researcher's fault, that's the mining company too. Mining companies are very big, and the people at the mine sites are very different than the people at the corporate office, and you have to get through all different layers to understand the truth and to be successful. I think mining companies know they need to change, they want to change, they want to do things quickly. You'll get individuals who are very definitely supportive of technology, or groups of people, but then they want things quickly. And I spent most of my last few years with Anglo American trying to convince people like yourself that things didn't have to be perfect, and we wanted things to try and do it quickly, and a sandbox approach. And so you've just got to find the right people in the right. If you deliver a solution that adds value, if it's something they want, they will want to try it. The problem is that usually people come with a solution that's not needed, or not top priority. So yeah, I challenge the mining industry will adopt new technologies, and they're not that conservative, but it has to be a win-win situation.
I'd like to pick up on one of the words you used, which was the word risk, and I'll give an example. Tailings dam failures. We have 2 to 4 tailings dam failures worldwide. We continue to have them every year. Some of them are more famous than others because they occur in a first world country like Mount Polley in 2014 in Canada, or Samarco, which affected 2 major world mining companies. The year before, that was in 2015. In 2014, there was a failure in Brazil of a tailings dam that killed people. No one heard about it because it wasn't BHP or Vale's operation or ownership. But it's an interesting question, risk. Can you afford the risk not to do something about tailings dam failures? In my view, tailings dam failures shouldn't happen. They just shouldn't happen. We don't get water dam failures at the same rate that we get tailings dam failures. And I think from the industry's point of view, the industry can't afford not to invest in doing something to change their practices and improve their monitoring so that they don't get tailings dam failures. Because the value of risk is enormous. BHP arguably lost $30 billion of shareholder value immediately following that failure. Vale wasn't worth quite as much as BHP at the time, but they lost probably $10 billion. They've recovered quite a lot of that because commodity prices have gone up, and they might think, well, perhaps it wasn't real anyway, we didn't really lose that money. And then you look at the response to that risk. There's no doubt BHP and Vale, probably more so BHP, has done a lot of work to try and redress the way they approach tailings. But if you look at how it's translating into the design of new tailings dams or the design of raises of existing tailings dams, that's largely done by consultants. It's not done by the mining companies. And the consultants have become ultra-conservative. So we're now putting partial factors of safety on top of partial factors of safety, so the ultimate factor of safety is enormous. But they haven't improved at all the safety practice. They haven't addressed the real issue. They're not improving monitoring. Which tailings dam in the world do you think is now the best monitored in the world? Have a guess. Samarco. But it doesn't even exist anymore. The dam's gone. It's gone. It's down the river. And they're not operating. But they've got the best surveillance system,